In this section, we're going to actually finally graph the linear equations instead of just plotting points. Although plotting points, as you'll see, is essential to graphing these linear equations. Let's look at our first problem. Here we have again the x and y axis. Again, let's remember that the horizontal axis is called the x-axis, the vertical axis is called the y-axis. The point of intersection is referred to as the origin. Numbers to the right of the origin along the x-axis are positive. Numbers to the left of the origin on the y-axis are negative. Similarly, up and down the y-axis, if I start again at the origin, the numbers above the origin are positive, so I have positives going this way. And similarly, going down the y-axis, my coordinates are negative. So there's the coordinate system. Now, what we're going to do is actually graph a linear equation. Our linear equation is going to look like this. X plus y is equal to 4. Now again, the reason why we call these linear equations, if you hear that word line in the word linear, that's exactly where it comes from. Instead of calling these line equations, mathematicians want to make them sound a little better, and so they made the word line into the word linear. Therefore, we have a linear equation. Now, what we're going to do then, in order to graph this linear equation, and notice this in terms of x and y, is we're going to find a couple of points that lie on that line. Now remember, basically all you need are 2 points to graph a line. So we can find just 2 points that lie on this equation, x plus y equals 4, plot them on the coordinate system, connect the dots, we'll have the graph of the equation. Let's begin. X plus y equals 4. What we're going to set up right next to it is what we call a T-bar of values. Now notice it looks kind of like the letter T there. That's why it's called the T-bar of values. What we're going to do is use this to hold some ordered pairs that we find that lie on our line here. So here we have x, and we're going to find x and y values, or basically we're finding, again, ordered pairs. So an easy way to start, and this is called the method of intercepts, is to find the points where our graph, when we graph it, crosses the x and the y axis. Now why is this an easy method to use? Because we know that all along this x-axis, our y value is equal to 0. So if I let y equal 0 in my T-bar of values, and I go back to my equation here, I can see the x plus 0 equals 4, or in other words, this is 0. Right away I can tell pretty easily that x is equal to 4. Now, this is exactly where our graph is going to cross the x-axis. Another easy point to find is where our graph crosses the y-axis. Now, along the y-axis, x is always equal to 0. Look at any point. For instance, this one here is a point 0, 1, 0, 2, 0, 3, etc. So again, all along this y-axis, x is equal to 0. So I'm going to take my value x equals 0, and just as I did in the previous problem, I'm going to substitute it right into this equation. Now if x is equal to 0, what happens is that's gone, and I'm left with simply y is equal to 4. So I'm going to put that in for my y value. Now what is this information telling me? This information is telling me the following. Now you don't have to do this every single time, but I'm just showing you exactly what this T-bar of values means. It means that the ordered pair 4, 0 lies on that line, as well as the point 0, 4. So now my job is to plot these 2 points on my coordinate system here. 4, 0. Remember, always start at the origin. 4, 0 means I go to the direction positive 4 along the x-axis, and I don't go in any direction on my y-axis. So there it is. I have 4, 0. 0, 4. Again, starting at my origin, I'm going to not go in any direction on my x-axis since x is equal to 0, and then go 4 for my y direction, and that's positive 4. Once I plot those 2 points, In order to graph the line, all I have to do is connect those dots. It's kind of like connecting the dots. We're going to take a straight edge here, put it between those 2 points, and simply draw the line. There it is. So there's the graph of the equation x plus y equals 4. Now, what we can do to clarify that this is the graph of x plus y equals 4 is we'll actually write our equation x plus y, oops, that's a y, x plus y equals 4 right there on the graph, so that when we look at the graph in this coordinate system, we know right away that the graph or the equation of this line here is x plus y equals 4. Do you get the idea? Let's try another. Now what we're going to do is take and graph another linear equation on the same set of axes. So let's go ahead, and this time we're going to graph the following equation. 2y minus x is equal to 6. So our job now is to graph this linear equation again on the same set of axes. Now I'm going to do this in another color just so that you can see which, so you won't get confused. What we're going to do is graph on the same set of axes here. This one's already done. We're going to find a couple of ordered pairs that lie on this line, plot it up here, and again connect those dots. So again, we have the equation 2y minus x is equal to 6. We'll employ again the method of finding intercepts. I'm going to let x equal 0. If x is equal to 0, what I like to do is just take my hand and put it over that x value, because then I can see that the equation I have left is simply 2y equals 6. If 2y equals 6, I can easily calculate that y is equal to 3. So far we have the ordered pair 0, 3. Now similarly, we're going to take here y equals 0. When y equals 0, notice I'm left with the equation negative x is equal to 6, or simply x is equal to negative 6. So again, I have two ordered pairs that lie on this line. In order to graph my line, I'm going to plot both points. So I start with 0, 3. Starting at the origin, go up 3, 1, 2, 3, put a dot. And then I'm going to plot my point negative 6, 0. Starting at the origin, I've got 1, 2, 3, 4, 5. Negative 6 will be right next to that, so let's add it in. Negative 6, 0 is right there. And now to finish the graph, all we have to do is take our straight edge, connect the dots, and draw the line. We'll extend it a little bit here, and it goes out in this direction. And again, just to clarify the equation, or excuse me, the graph here, we'll write the equation of the line 2y minus x is equal to 6 right on that line, so there's no question for the people looking at it. They know this equation here is 2y minus x equals 6, and this one is x plus y is equal to 4. Now that's graphing a couple of equations. Let's move on to see what other kinds of lines we can graph. So now we're going to take and graph the following equations. We're going to graph this one, 2y minus 3 is equal to 0. Right away you may notice the big difference between this equation and the ones we just finished graphing is the fact that there's no x involved. Now how's that going to affect the graph of this line? Well, we'll return to the same method, which is using that TBar values, and let's see what happens. Well, first of all, let's go ahead and just solve this equation for y, since that's the only variable there. So this gives us 2y equals 3. Divide both sides by 2. Y is equal to 3 halves. Now, notice that x is not involved in the equation at all. How does that affect the graph? Well, it tells me that there are no stipulations on the value of x. In fact, x can be anything it wants. It will not affect that equation. So I can choose a couple of points. For instance, I could choose 1. If x is 1, what does it do to my equation? Does it change the value of y? No, y is equal to 3 halves. How about if I choose x is equal to negative 2? How does that change the value of y? Well, it doesn't. I still have 3 halves for y. So now I have a couple of points. Remember, it takes 2 points to graph our line. 1 3/2 means I start at 0, 0, go over 1, go up 3/2, which is 1 1/2. So 1 1/2. There it is. Let's try our second point. -2, 3/2. Again, starting at the origin. -2, 1, 2, going up 1 1/2, 1 1/2, and there we have it again. Now, do you see that no matter how many values I choose for x, y is always going to be equal to this 3/2 here? Let's just throw another one in for fun. If I went over x equals 2, y is still 3/2. In fact, if I did that so many times, you see what's going to happen here? That I'm going to get this horizontal line, oops, right there, that's parallel to my x-axis. So the equation of this graph is, as we just saw, y equals 3/2. Just to extend this a bit, if I were to ask you then to graph y equals -2, do you see that would be, here's 1, 2, negative, the graph parallel to y equals 3/2, that would be y equals -2. In fact, these are probably the easiest kinds of equations to graph. You just have to remember which way it goes, horizontal or vertical. Now, these are the horizontal graphs. Let's look at another one. What happens if instead of the x being missing, the y is missing from our equation? Let's graph x plus 3 is equal to 0. Solve this equation for x. X is equal to -3. Now, again, this equation tells me that it doesn't really care what y is. All it really cares is that x always has to be -3. So again, it's your choice to choose values for y. So let's just choose 0 and 2. It doesn't matter what you choose. Let's see what happens when we plot these points. X is -3, 1, 2, 3, y is 0. So it stays on the x-axis. That's my first point. My second point, -3, 2. Over -3, up 2, 1, 2. In fact, if x is always -3, and it doesn't matter what y is, can you see what's going to happen here? What's going to happen is that I'm going to get a lot of points all along this vertical line. And the equation of that vertical line we just saw is x is equal to -3. So as a little summary here, every vertical line is going to have the equation x equals something. Every horizontal line is going to be y equals something. It just takes a little practice. A lot of students get confused, but if you'll just pick a point on the line, you'll see that this is not x equals something. This is y is always 3/2. This is always x equals -3, and that gives you the equation of the special case of the horizontal and the vertical line.